Okay, so this is that trapezoid video that I said that I was going to give if you have time and still need help. So I'm going to this decomposition page of trapezoids, and so it's page 9, and I'm going to go down and I'm going to do problems 9 and problem 10, and I'm going to do it both the decomposition way and using our area formula. Okay, I'm going to do area formula first, and then I'll do decomposition on the left. And this is only for people that feel like they need extra help with our trapezoids. Okay, so my area formula for a trapezoid is area is equal to, and in parentheses, base 1 plus base 2 multiplied by height and then divided by 2. Base and height have to have the relationship of perpendicular, which means we're looking for where we have that 90-degree angle box and the two measurements that form it. Bases have to be parallel. This is where I had you all hold up your arms, and I said you can't have any cocked elbows. This was what we had when we had cocked elbows. So if we look at problem 9, those are my cocked elbows. I can't use those measurements, okay? If we look at problem 10, that measurement of 28, that is a cocked elbow. It's not going to be a used measurement, okay? So we don't want to use any cocked elbows. Y'all ever see those traffic signs that are red and it has the line through it? That's what I want there. No cocked elbows. Okay, we're either going to look at perpendicular or we're looking for parallel. Okay, bases have to be parallel. So in problem 9, my two sides that are parallel, they stay the same distance apart, or what I have highlighted in red there. In problem 10, my two bases that are parallel, even though they're turned, remember I had us hold up our arms and I said it was fine if I turned so that my arms were diagonal as long as I kept my elbows in. So those two in red are going to be my bases. My height, I'm going to do in yellow here. It has to be perpendicular, so in problem 9, it's that dotted line down the middle because it's just a trapezoid. But in problem 10, because it's a right trapezoid, I have it as one of the sides on the outside of my trapezoid. Okay, so we're just going to plug our values into our trapezoid formula. So for problem 9, I have 14 and 2/10 plus 6 and 8/10. My height is 9 and 5/10, and then I'm going to divide by 2. Area, or my order of operations, I have to do my parentheses first. So 14.2 plus 6.8 gives me 21. So now I have 21 times 9 and 5/10 divided by 2. 21 times 9 and 5/10 is 199 and 5/10. And when I divide by 2, I get 99 and 75/100. It is area, so it should be millimeters squared. Okay, problem 10, I'm just going to plug my numbers into my formula. So I have 16 plus 42 and 5/10. Those are my bases. My height is 9, and then I'm going to divide by 2. So I'm going to add first 16 plus 42 and 5/10. And I got 58 and 5/10. Multiply that times 9 divided by 2. So I'm going to multiply times 9. And I got 526 and 5/10. I still have to divide by 2. And that gives me my 263 and 25/100. And that would be millimeters. Nope, sorry, this one says inches. Inches squared. Okay. I'm going to go ahead and erase my markings on there. And I am going to find my area using decomposition, okay? So I'm going to work on problem 10 first because it's a right trapezoid, which means I'll have one rectangle and one triangle. Right where I have that diagonal cocked elbow side, I'm going to try and draw my straight line down. So now I have shape 1 is my rectangle and shape 2 is an identical triangle. Okay, that value for 9, that's the height of my rectangle, is also going to be the value for the height of my triangle, because opposite sides of a rectangle are congruent. So shape 1 is my rectangle. Rectangle's area formula is base times height. So I'm going to have 9 times 16, because those are the two values that meet at that 90-degree angles. Shape 2 is my triangle. I have the 9, because it's that same opposite sides of a rectangle are congruent. I have not figured out my height yet, but then it'll be divided by 2. Okay, so when I look to find my height, I know that this base that includes the 16 from my rectangle and the base of my triangle, they together add up to be 42 5/10. So I can find just the length of the triangle, the base of the triangle there, by subtracting from my 42 5/10 that length of the rectangle, that is 16. So I'm going to do 42 5/10 minus 16. I get 26 5/10. Okay, so now I'm going to solve my two formulas. So for my rectangle, 9 times 16 is 144, and this would be inches squared. For my triangle, I don't have any even numbers, so I'm going to multiply first. So 9 times 26.5 is 238 5/10. When I divide by 2, I get 119 25/100, and this would be inches squared. So my last step is to add those two values together. So 119 25/100 plus 144 is equal to 263 25/100 inches squared. Okay, problem 9. Whenever we have just a trapezoid, so it's not a right trapezoid, when we break it apart, we're going to have two triangles. I like to solve them as they're identical, even though when we look at this one, they are clearly not going to be identical. Remember I showed you guys in class with this example right here, that if I don't make the base of my triangle equal, if I don't make it 4.5 on both sides, if I made it 5 and 4 or 6 and 3, or even 8 and 1, I'm still going to get the same two combined area for those two triangles. So if you want, you can make them identical so that you only have to solve one area formula for a triangle. Okay, so that's what I personally like to do. It's okay if that's not what you like to do. Okay, so right where those slanted sides start to caulk, that's where I'm going to draw my straight lines as best as I can so that I can see my two triangles. So I have triangle 1, triangle 2, and then I'm going to make my rectangle 3. Okay, so 1, 2, and then 3. Okay, I'm going to work with my rectangle first. I know opposite sides are congruent. Okay, that height that goes through my rectangles, that dotted line that's 9 5/10, that's going to be my height of both triangles, and it's going to be the height of my rectangle. So I have that 9 5/10 because opposite sides are congruent. Okay, my base for my rectangle, I have 6 8/10, which means the opposite side there. So this part that I'm going to kind of highlight in blue there, that is 6 8/10. So that goes in as my other measurement for my rectangle. Okay, it's also what I'm going to subtract from my 14 2/10 so that I can find the two measurements that are on either side of that blue line. So I'm going to take 14 2/10 minus 6 8/10, and I got 7 4/10, and that is for both sides because I like to treat them as equal. I'm just going to divide that by 2 so that I have what those individual sides would be. I got 3 7/10. This is where if you don't want them to be equal, you could use different measurements. Like you could use 0 4/10 for triangle 1, and you could use the 7 for triangle 2. Okay, the choice is yours. I personally like to make them equal, so I'm only solving for the triangle once, and then I just double that answer for triangle 2. So I have 3 7/10, and then it is always divided by 2 for my triangles. So now I am going to solve my area formulas. So starting with my triangle, I have 9 5/10 times 3 7/10. I got 35 15/100 divided by 2, and I got 17 575 thousandths. It's an ugly number, but it is the correct number. It would be millimeters squared. So that is the same value that I would have for triangle 2. Okay, so whenever we're done, we're going to be adding all 3 of these together. So I'm going to write it down at the bottom because it's kind of smushed up there. And now we have triangle 3. So I'm going to take my 9 5/10 times 6 8/10, and I meant rectangle, my shape 3. And I got 64 6/10, and it would be millimeters squared. So that's the last value that I need to add for me to find my total area. And I got 99 75/100, which is the same thing I got on the other side, millimeters squared. Okay. If you were somebody that wanted extra practice, I know these ones didn't have the most friendly of numbers, but here was your extra practice, and now you would go and work on your WIN packet page 1 through 9.